All right, so this is Unit 7, Day 12, which was meant to be a day to put all the different methods for solving a quadratic together, so you can practice and see the differences between the methods and just get some practice. So my plan is to do one of each kind with you, and then you are to do the rest of them for the homework for this day's notes. So remember, you have learned 4 ways now to solve a quadratic equation. One is graphing and finding the roots. Another one's completing the square, solve by factoring, or quadratic formula. And the latter 3 are all considered algebraic methods, which means if they say solve algebraically, you have your choice on how to do it. All right, so I'm going to do number 1. And it's to solve graphically. So solve graphically means we got to draw a graph. So we're going to put it in y equals x squared plus x minus 6. We're going to go get a table. And we're going to look for that repeating y pattern. And we're going to write the table down because we have to. So I have -3, 0, -2, -4, -1, -6, 0, -6, 1, -4, and 2, 0. So the first thing I notice is that my vertex is missing. And I know that I'm supposed to have an oddball point right here in between those -6's. So over here on the x, I know the x value is going to be halfway between that -1 and 0. So that means my axis of symmetry should be x equals -0.5. And now to find the y value to go with it, I need to plug it into the equation. So y equals -0.5 squared plus -0.5 minus 6. Now, most likely, the vertex has absolutely nothing to do with my roots. So why am I wasting my time finding it? Because it says solve graphically. And in order to solve graphically, I have to draw the graph. And in order to draw an appropriate graph, I must have the vertex on it. And if I don't, then I am going to get marked points off for having an incomplete graph. So when I plug in the -0.5 into the equation, I get -6.25. So now I know my vertex and I can graph a good graph. I'm going to blow this up so that I can draw a little easier. So I draw my x and y axis. And you still have the table in front of you, hopefully. So let's see, -3, 0, -2, -4, -1, -6, -0.5, -6.25, and 0, -6, 1, -4, and 2, 0. All right, make a nice curvy U shape. Put arrows on the end, and of course you should label it. So I'm going to call that graph A. I'm going to call that graph A. Now it said solve graphically, and I've drawn the graph, and that's great, except that I haven't actually answered the question yet. Solve means I need to find the roots, and the roots are where it crosses the x-axis. So I'm going to write down -3, and I'm going to write down a 2, and I'm going to put a box around my answer because those are the roots. All right, one of the algebraic methods that you learned was completing the square. I am going to do number 3 with you. Number 3 has the same kind of extra step that number 6 has, just to forewarn you. I don't like the 0 equals on the left, so I'm going to stick it on the right. It's an equality, so you can flip sides. I am noticing that the number touching the x squared is a -1, and I can't complete the square unless it's just a regular 1. So I need to divide everybody by -1 first so that all it says is x squared. Don't forget, you have to show dividing the 0 as well. So -1 divided by -1 makes just a x squared because they cancel. And positive 4x 2 divided by negative 1 is negative 2. 0 divided by anything is 0. All right, so now that we have a regular x squared, we are ready to complete the square. 4 main steps. Get the constant to the other side, so we add 2. And then off to the side, take half the b and square it. b touches the x, so it's 4 divided by 2 is 2. Square the 2, you get a 4. Take that 4 and add it to both sides. X squared plus 4x plus 4 equals 2 plus 4. Clean up the right side, make it a 6. Factor the left side without thinking. X goes there, your half b, the positive 2, goes in parentheses with it. That's by design. Don't waste your time doing factor by grouping. Square root both sides. Square and the square root cancel, leaving you with an x plus 2. Positive and negative. You just added a square root that wasn't there before, so you need a positive negative answer. Square root of 6 cannot be simplified. It breaks down to 2 times 3. There's no groups. Now I get x alone by subtracting 2. Put the pretty number first, plus or minus the ugly number second, and you are now done with completing this square. If that wasn't enough to jog your memory, then you should go back and open the lesson where I taught completing the square a couple lessons ago and review it and go through the steps again. All right. Next, solve using quadratic formula. This tends to be everybody's favorite. The quadratic formula is on your formula sheet, which you all should have a copy. Okay, so I'll write it here. All right, so completing the square is the only time you don't want to set the quadratic equal to 0. So we need to move everything to one side and make this equal to 0. So I'm going to subtract the 1. 2x squared minus 4x minus 1 equals 0. Then I'm going to write down what my a, b, and c are. A, touching the x squared is 2. B, touching the x is negative 4. C, the constant, is negative 1. And we're going to go plug those in. X equals negative. Wrap that negative 4 in parentheses for the b. Plus or minus. Hug that negative 4 again. Squared. Minus 4 times 2 times hug the negative 1. All over. Get that bar all the way across. 2 times 2. All right, cleanup time. Negative negative 4 makes positive 4. Type everything underneath that radical. Do not type the radical itself. So we get negative 4 in parentheses squared minus 4 times 2 times negative 1 comes out to be 24. 2 times 2 in the denominator makes 4. Now if I type in square root of 24 into my calculator, it comes out to be a yucky decimal. We don't want that, so we need to simplify. So over here on the side, I'm going to simplify square root of 24. That's 2 times 12, 2 times 6, 2 times 3, hockey stick. One group of 2, so a 2 comes out, this 6 stays in. So that now gives me x equals 4 plus or minus the 2 that came out. 2 and the 3 come back together to make 6, all over 4. Then I draw a heart around my pretty numbers. 4, 2, and 4 are all even. That means a 2 comes out of each one of those. So 4 divided by 2 is 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So my final answer is x equals 2 plus or minus 1 square root of 6 all over 2. Okay, my two irrational answers all mixed up. All right, so I will remind you for a problem like number 9, you are missing a term. When you're missing a term, you are supposed to use a 0 for that letter. Okay, and solve by factoring. Now, you haven't done this in a long time, so maybe I'll review a couple of them with you. but somewhere back in Unit 3.5, you did polynomials, and you have a nice little flow chart that tells you how to factor. So the GCF is what you look for first, then it's 2 terms versus 3 terms. And if it's 2 terms, you're looking for difference of squares. And for 3 terms, you're going to do factor by grouping unless you know the shortcut. Okay, so let's do a couple of these. We'll do number 11. So first thing though is you must have the equation equal to 0. Okay, just like with quadratic formula. So everybody's got to be on the same side first. So number 11, it's already equal to 0. So first thing you do is look for a GCF. 2 will go into all the terms. So you write down the 2, put a parenthesis, and then whatever you get when you divide by 2 goes in the parenthesis. So that'd be x squared minus 16 equals 0. I see 2 terms in the parenthesis. Is it difference of squares? Difference means I have a minus sign. Yep. Perfect square means I can take the square root of it. Well, square root of 16 is 4. So yes, it's difference of squares. 2 comes down. When you have difference of squares, you get the same thing in parentheses, except one's got a plus and one's got a minus. So x times x is x squared. 1 minus 1 plus. 4 times 4 makes the 16. I still have my equal 0. From here, that was the factoring piece, but it says solve. So when it says solve, I have to keep going. You take each of your factors and set it equal to 0. I have 3 of them. So 2 equals 0, which doesn't make sense. 2 never equals 0. This is called an extraneous root. It has no variables. Cross it off and reject it. Then x minus 4 could equal 0, or the x plus 4 could equal 0. Add 4 to both sides. 1 root is 4. Subtract 4 from both sides. The other root is negative 4. So that tells me if I were to graph that parabola in question number 11, it would cross the x-axis at 4 and negative 4. I'm finding the roots. I'm just doing it algebraically. All right. Yeah, let's do 13. So 13, again, everything is on one side. It's equal to 0. First thing I look for is a GCF. I can't think of anything that divides into 6 and 19 and 10. So I'm going to say, nope, there is no GCF. There are 3 terms, which means we're going to do factor by grouping. You can't even do the shortcut on this one anyway. So factor by grouping it is. Front times back. 6 times 10 is 60. List all the ways to multiply to 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. I need a pair of numbers that adds up to a negative 19. Well, none of these are going to add up to negative because they're all positive. But here's a pair that adds up to a positive 19. Since I need a negative 19, I'm going to change both their signs and make them both negative. All right, from here, the middle term comes out. Those 2 numbers go in. So 6x squared minus 4x minus 15x plus 10 equals 0. Make groups of 2. Take the GCF of each group. GCF of the first group is 2x. Write it down and divide. 6x squared divided by 2x is 3x. Negative 4x divided by 2x is negative 2. GCF of the next group, since the next group starts with a negative, the GCF has to be a negative, and 5 will go into both of those. So we're going to divide both by negative 5. That's going to give us a positive 3x, and 10 divided by negative 5 is negative 2. My parentheses match, which is a good thing. So my final factors are 3x minus 2, and the little GCFs go in parentheses, 2x minus 5, and I still have this equals 0. So if the problem had just said factor, I'd be done. I broke it up into the parentheses. But since it says solve, I am actually looking for the roots on the graph. So this is where I take each parenthesis and set it equal to 0 and solve for x. So add 2 to both sides and divide by 3. So it says one of my roots is 2/3. If I add 5 to both sides, divide by 2, x equals 2.5, or you can leave it 5/2. So I got nice rational answers. So the factoring worked out well. I could have used quadratic formula and got the same answers. But if I tried to graph it, since those x values are fractions and decimals, it never would have shown up on my table. So solving by graphing would not have been very helpful here. But it did say factor. All right, there's your 2 roots. That is the end of the problems that I am going to do with you. You are to do the ones we have not done together as the homework for this lesson.